Hi everyone, welcome to Crystal Clear Chemistry channel. In this video, I am going to discuss 25 questions of JEE mains level, and this is the first model paper that I am going to upload in my channel. Like this, I am going to upload the model papers of MSET and NEET level also. So for more updates, please subscribe to my channel. The first question. They have given the complex ions, the four complex octahedral complexes they have given, and they exhaust the wavelengths of the region red, green, blue, and yellow respectively. What is the strongest ligand among the A, B, C, D? Suppose if the ligand is strong, it readily absorbs higher energy radiation. It readily absorbs higher energy radiation. If energy is high, we can say that the wavelength is less. Wavelength will be low. So, stronger the ligand, more is the energy, lesser will be the wavelength of the radiation. Based on this, we can say that the one which readily absorbs the blue color with lower wavelength among the given colors will be the stronger ligand, and this blue is meant for this ligand C, right? So C is the stronger ligand among the given, the strongest among the given. I hope you understand it well. Next, wavelength of the electron goes in the two Bose orbits is in the ratio 3 is to 5. The ratio of kinetic energy of the electron they are asking. So wavelength ratio they have given, and they are asking for the Ke ratio. We have the relation lambda 1 by lambda 2 is equal to square root of Ke2 by Ke2 by Ke1. So based on this relation, we can easily calculate the kinetic energies ratio here. So lambda 1 by 2, lambda 1 by lambda 2 means 3 by 5. If we do the squaring on both sides, you will get 9 by 25 as Ke2 by Ke1. But if we want Ke1 by Ku2, we have to reverse the fraction so that we will get 25 by 9. Answer will be 2.78. Next, assertion design type question. Assertion. Chlorobenzene is more reactive than benzene towards Friedel-Crafts alkylation. No, it's not correct because chlorobenzene, if we consider the minus I effect of the chlorine makes less reactive than benzene. Once again, if we consider chlorobenzene, no doubt chlorine shows plus R effect. Because of the plus R effect, it orients the next incoming substituent towards argo and para. But if we consider the reactivity definitely depends upon this inductive effect. And here the minus, because of the stronger minus I effect of chloride ion, chloro group, the chlorobenzene will be less reactive when compared with the benzene. But they have given more reactive, that means the assertion is wrong. Let us see the reason. The positive mesomeric effect of the chlorine governs the orientation effect of the electrophilic aromatic substitution reaction. Yes, it's correct. As we discussed now, the plus R effect of the chlorine directs the incoming electrophile towards argo and para. That means it's the argo para director. In simple words, we can say that though the chlorine is argo para director, it is less reactive than benzene. So the reason is correct, but the assertion is wrong. The answer will be the D1. Right? Now, let's move to the question number 4. Which of the following reaction is correct match of the given energy profile diagram? So if we look at the diagram, reactants after getting the activation energy directly converting into the products, we can say it's a single step reaction, right? So it is a single step reaction. Next one, again assertion type. question. And even in recent mains question papers also, if we observe, more of statement type and assertion result as questions they are asking. So practice more of this kind of questions. Anyhow, the assertion is the styrene on reaction with the HBr gives 1 bromo 1 phenyl ethane. Let us see styrene. Styrene, if we consider on benzene, there is a vinyl group. This is the styrene, CH double bond CH2. And whenever the HBr attacks, no doubt the one of the bonds shift towards one of the carbon atom. Here, if we consider, because of the movement of these pi electrons, we get this carbon gets positive charge, which is stabilized by the resonance, and this Br readily attacks here, and this H readily attacks here. That means here bromine we will get, and here CH3 it becomes. That means this is the one bromo and one phenyl, and this is ethane. So no doubt the assertion is correct. What about the reason? The benzyl carbocation is more stable due to resonance. Yes. Here the movement takes place from this carbon to this carbon. It is because this benzyl carbocation is stabilized by the resonance. Right? So both A and R are correct, and R is the correct explanation of assertion. Right? Let's move to the next question. A positive carbyl element test is given by carbyl element test. It is meant for primary amines, right? So if you look at all these options, the primary amine will be, see, NN dimethyl. That means it's unsubstituted. It's a tertiary amine. N methyl. This is the secondary amine. This is N methyl again. So secondary amine. P methyl benzyl amine. This is the primary amine. So this will be the answer. Next one. If R is the concentration of the reactant, which of the following is correct match of the given graph? Here, with the time, the concentration of the reactant decreases. Means it's a zero order reaction, right? Especially in the case of chemical kinetics and thermodynamics, especially in chemical kinetics, you will get graph type questions frequently in the mains. So just concentrate on the graphs in the chemical kinetics chapter. Let's move to the next one. A gives products. A naught, initial concentration they have given as 2m. After the 10 minutes reaction, after 10 minutes, the reaction is 10% completed. If minus dA by dt is equal to K into A, then T 50% they are asking for. Here they have given the rate equation. From rate equation, we can say that the order the order is 1. So for the first order reaction, they are asking for 50%. Means first we need to calculate K. How to calculate K? That is nothing but K 2.303 by T into log A by A minus X, right? So they are given 10 minutes in 10% completed. So if A is taken as 100 and X is taken as 10 and T is taken as 10 minutes, you will get the K value first. It will be around 0.01 second inverse. But they're asking for T 50% and T 50%. How to calculate? In first order reaction, T half is equal to 0.693. Sorry. So wait. So just bear with my handwriting, as it is first time I'm using this pen tablet. So 0.693 by K. So by substituting the K value here, you will get the T 50%. It will be around 69.3 minutes. Next one. Which of the following does not show allotropy? Among 15th group elements in the nitrogen family, nitrogen cannot show the allotropy. So the answer is C. Especially in the groups, we need to concentrate more on physical and chemical properties of all the elements. From inorganic chemistry, it's an easy topic, so you can score well in the inorganic chemistry. So don't neglect the groups. Which of the following has maximum electron gain enthalpy? Halogens. It's a basic question. We know already the chlorine electron affinity is high when compared to fluorine. It's an exceptional case because the fluorine is a small atom. Repulsions will be there among the inner electrons. So the order will be chlorine greater than, fluorine greater than, bromine greater than iodine, right? So, what is the correct answer? This B is the correct answer. Next one. They have given a graph again, and electronegativity values they have given. All these elements are successive members of a group in the increasing order of their atomic number. En is the electronegativity of the corresponding scale in Pauling scale, corresponding elements in the Pauling scale. Find the correct group. If we observe this particular straight line, the electronegativity is almost same except for the first element, second, third, fourth elements, and for the last element slightly up. Definitely it must be a 14th group elements. If you consider the carbon family, among the carbon family, this is the carbon, silicon, germanium, tin, and this particular thing is lead, which is having exceptional case in electronegativities, atomic sizes, and all due to inert pair effect and all. So remember, uh, the electronegativities of all the elements are almost same for the 14th group element. So which is the correct one? This B is the correct one. Next, what is the spin-only magnetic moment of Zn plus 2 ion in Bohr magneton? Zn plus 2. If we consider Zn plus 2, the configuration is 4s0 3d10, right? 4s0 3d10. No unpaired electrons. That means n is equal to 0 implies mu also 0. So the answer will be C. Let's move to the next one. So which of the following species do not show disproportionation reaction? Disproportionation reaction. In order to show disproportionation reaction, the central atom must undergo both oxidation as well as reduction, right? Uh, do not show disproportionation reaction means it should not undergo one of the reaction, right? The element which is in its lowest oxidation state can only undergo oxidation. The element with in its highest oxidation state can only undergo reduction. If it is in the intermediate oxidation state, it can undergo both oxidation and reduction. If we consider ClO4 minus ion, that is perchlorate ion, in this the chlorine oxidation state is +7. Uh, as it is in its highest oxidation state, it can only undergo reduction but not oxidation. That means it cannot show the disproportionation reaction. If we observe the all other elements, I mean all other oxidation states of the chlorine atom in the remaining options, they are the intermediate oxidation state. For example, if we consider this one, this is +1. It can also undergo -1, 0. It can also undergo +3, +5. This is +3 and this is +5, +7. So anyhow, not showing the disproportionation is this D, because in already the chlorine is in its highest oxidation state, right? Let's move to the next one. Which of the following is extensive property? For extensive properties, there is one mnemonics. For example, if you consider USHG, or you can remember it as a GUSH, GUSH, gives free energy, internal energy, entropy, and enthalpy. All are extensive properties. So here the enthalpy is the extensive property. As my name is Usha, here instead of here I remembered it as G. You can remember it as Gush, right? So Gush is not all our extensive properties. Yes. Let's move to the next one. Calculate the pH of 0.08 molar solution of hypochlorous acid. Ka, the ionization constant of the acid, that means Ka they have given Ka, and they are asking for the pH of the solution. pH, how to calculate? We know it is the negative logarithm of H plus ion, right? It is the negative logarithm of H plus ion. Then how to calculate H plus ion? H plus ion is nothing but, see, for Ka, if we consider, it's nothing but H plus ion concentration. 1 minute. K is in a simple formula. If we consider H plus ion concentration is equal to square root of Ka into C. Ka into C. So this is the Ka value and this is the C value. By multiplying, you will get the after the multiplication and the square root of that product, you will get H plus ion concentration. And if we substitute here in the pH, you will get the pH value. Here the pH value, I think it is around 2.80. Let me check once. Yes, it's, it's above it. It's 2.85 we get here. So you calculate, then definitely you will get the answer as a 2.85. Next one. Ionic product of water is 10 power minus 12 at 90 degrees centigrade. So H plus ion concentration to H minus ion 10 power minus 12. In that case, the neutral pH is 6, right? If it is 14, it would have been 7. If it is 12, it is 6. Then how many of the following samples are acidic in nature? Those samples which are having the pH value less than 6 will be acidic in nature. So let me check which are less than 6. This 5.2. Oh, only 5.2. So that means only one sample is acidic in nature at this 90 degrees temperature. So the answer will be D. Let's move to the next one. For SF4, suppose if we consider SF4, how to predict the hybridization? We have half VLCA rule, right? What is that? Half V plus M minus C plus A. This is half VLCA rule. Half into V means valency. Suppose if we consider the sulfur, the valency of the sulfur, the number of valence electrons are 6. So I am writing as 6 plus uh, M means monovalent atoms. Fluorine, if we consider it, it only forms single bonds with that of the central atom S. So there are 4 single bonds. So 4 monovalent atoms. Minus, there is no positive charge here associated with it. So 0. A means the anion charge, that means negative charge. There is no anion here. So that is also 0. So how much we are getting here? Half into 10 we are getting, that means 5 we are getting. This 5 represents the number of hybrid orbitals that are formed after the hybridization. When there are 5 hybrid orbitals, definitely we can predict that it as sp3d. sp3d. So SF4 must be sp3d, that will be E, right? Now, suppose if we consider SO2, Mm, let me calculate. Let me show. Okay. Anyhow, let's move to the SO2. SO2 means it is again half into 6 plus this time no valent atoms, no monovalent atoms. So 0. That means it is 3. 3 means it is definitely sp2. So 2 and sp2 where it comes? Here it comes. 2 and sp2. So 1e and 2d. So after calculating few, let's check the options first. 1e, this one, and 2 is D. So this one. So this is the correct option. And if we check the remaining options also 3A and 5C, let me check. 5. First, let's 3 is A. Yeah, ZnCN of 4 times minus 2. It is sp3. And 5 is C. Yes, always the platinum undergoes DsP2 but not sp3. So the correct one is D. Next, 1 mole of KMnO4 can oxidize X moles of iodide in acidic medium. What is the value of X? In acidic medium, see for this type of questions, even we need not to know the balanced equation. Let us see how to calculate it in a shorter way. So suppose if we consider MnO4 minus ion in the acidic medium, it readily converts into Mn plus 2. That means total of 5 electrons are involved in the reaction. 5 electrons it is offering to the iodine. 1 minute. 5 electrons it should gain, right? 1 mole of KMnO4 should uh, reduce, can be reduced by 5 electrons. 5 electrons means if we consider iodide ion, I minus gives half I2 by providing 1 electron, right? So how many electrons KMnO4 want? 5 electrons. How many it is giving? Each iodide ion is giving 1 electron. That means 5 iodide ions it requires. So we can say that the KMnO4 can oxidize 5 moles of iodide ions in the acidic medium. So without knowing the balanced equation also, just by counting the number of electrons that are transferred from reducing agent between reducing agent and oxidizing agent, we can calculate the number of moles. Next one. CH3CONH2 plus Br2 plus XNaOH, CH3NH2 plus byproducts. What is the value of X? This is Hoffman bromide reaction, right? So Br2NaOH. Just by looking at this particular reactants, we can easily come to easily recognize that it has a Hoffman bromide reaction. As X value they are asking, coefficient they are asking. That means the balanced equation also we need to know. We know it is Br2 plus 4NaOH. So straight away we can keep the answer as 4. So this is one more question based on the named reactions. So as I said already, the named reactions, reagents and expecting the products are very important in mains point of view. The process with negative entropy change is positive entropy means the disorderness should increase. Negative entropy means disorderness must decrease. CaCO3 dissociation gives CO plus CO2. Here there is a solid on the left hand side and the gas is on the right hand side. So the disorderness is increasing in the forward reaction. So in the dissociation process. So this is not associated with a negative entropy. And if we consider the synthesis of ammonia from N2 plus 3H2, let me check. Uh, one N2. 1 minute. Yeah. So N2 plus 3H2. gives rise to 2NH3, right? All are gases. Reactant side 4 gases are there, product side 2 gases are there. So 4 gas molecules are converting into 2 gas molecules, means doneness is decreasing, that means entropy is decreasing, and you can say that it is associated with the negative entropy, right? Dissociation always the increase in the entropy, the sublimation also directly converting into gas state, no doubt the entropy increases. So negative entropy is associated with the option B. Let's move to the numerical type questions. We have done with the MCQs. Let's move to the numerical type questions. Find out the total number of aromatic compounds in the given compounds. Aromatic compounds. See, this aromaticity concept also very important. Uh, Let me check. See, suppose if you consider the benzene is aromatic, naphthalene is aromatic. No doubt, anthracene is with the fused rings of benzene aromatic. This is anti-aromatic. We know 4n plus 2 pi Huckel rule, but it is having only 4n pi electrons with the conjugation and the cyclic planar structure. It is anti-aromatic. And if we consider this particular cyclopropynyl cation, it is obeying the Huckel's rule, having the conjugation, having cyclic planar structure, having 2 pi electrons, in which 4n plus 2 pi electrons rule also it is following if we take n is equal to 0. So this is also a aromatic compound, right? So there are total 4 aromatic compounds are there. See, this type of ions are very important. Let me discuss in detail here. So, if we consider the cyclopropynyl cation, which is a 3-membered ring with a positive charge. Let's take a next odd number, that is 5-membered ring with a negative ion. This is cyclopentadienyl anion, and so this is 7-membered ring. Now let's move to the 9-membered. Sorry, this is 5-membered ring, right? 1 minute. Yeah. Sorry. So this is 5-membered ring, and let's move to the next odd number, that is 7 carbon atoms. So 7-membered. Yeah. 7-membered ring with conjugation along with a positive ion. Can you guess the ion here? Yes, this is propylium cation, cycloheptatrienol cation with a 7-membered ring. So, 3-membered ring with a positive charge, 5-membered with a negative charge, and 7-membered ring with the conjugation along with the positive charge. All are aromatic compounds which are obeying the Huckel's rule. Exactly opposite if we consider the negative charge, positive charge, and here negative charge if we consider, they are all anti-aromatic, which are least stable in nature. Definitely on this you will get a question. Very important concept, right? Yes. Let's move to the question number 72. Anyway, here the first question number 71. What is the answer? 4 is the answer, except this anti-aromatic compound. Let's move to the 72. The number of non-reducing sugars. Sucrose is a non-reducing sugar. Uh, yeah, we know sucrose is a non-reducing sugar. Starch, glucose, but if we consider this particular glucose is a reducing sugar. Apart from that, this starch, cellulose, or polysaccharides, all polysaccharides like starch, cellulose, etc., are the non-reducing sugars along with the sucrose. So, except glucose, all other are non-reducing sugars. So, the number will be 3. Reducing and non-reducing sugars are very important. So 15 here, 15, 34, 33, 52, 51, 84 are the atomic numbers of the elements of the p block. How many of them are metalloids? If we consider the arsenic As here, 33 is the arsenic, 34 will be selenium, 51 will be antimony, 52 will be tellurium. So only 4 metalloids are there. So 4. One should have a basic idea about the atomic numbers of most of the elements, S block, P block, right? Let's move to the 74 question. How many of the first series transition elements are heavier than iron? After iron, what are the elements? Nickel, copper, right? And if we consider the Zn slightly the radius expands, so it will be having less density when compared with iron. But if we consider cobalt, nickel, copper, all the three elements are having higher density than iron. So the answer will be 3. The last one, final one, electronic configuration of gadolinium they are asking for, and we know it is having the half-filled f orbital, so 4f7. They are asking for x only, so x must be 7 for gadolinium with the configuration 4f7, 5d1, and then 6s2, right? Yes, that's all for today. So thank you so much. Thank you one and all for bearing with my handwriting and all. Uh, if you like the video, please share and subscribe to my channel. Thank you.